So we have talked about global warming and the tipping points that exist in the Earth system in other contexts, in other courses. Here I wanted to include this podcast based on a new paper that came out from the common authors that appear on many of these papers. Mostly a European group or groups in Europe. It's not such a hot topic outside of Europe, it would seem. And the idea is not without its debates and controversies, because the uncertainty associated with the idea of how close we are to the tipping points is a little bit dicey in the sense that these are not directly predictable from the models yet, the IPCC class models. They do identify these tipping points, and when you run the models out into the future with increasing CO2 or greenhouse gases, you do hit some of these tipping points at various levels. What is controversial is the empirical derivations of tipping points being really close and without necessarily being sure about how uncertain these estimates are. So I will put this down here, and you take it and read the papers and try to make your own decision. I'll say a few more things about it at the end. So this is kind of the graphical abstract, graphical summary of the paper, which shows the cryospheric, biospheric, and ocean atmosphere and tipping points. So include the usual things we think of: Arctic winter, sea ice collapse, boreal forests, northern expansion, Greenland ice sheet collapse, Barents Sea ice abrupt loss, boreal permafrost collapse, boreal forest dieback, Labrador Sea subpolar gyre collapse, which would change the thermohaline circulation, which is now referred to as AMOC, or Atlantic Meridional Overturning Circulation, and its potential collapse as a tipping point. Boreal permafrost abrupt thaw, presumably releasing lots of greenhouse gases and having positive feedback. Amazon rainforest dieback, mountain glaciers loss, West Antarctic ice sheet collapse, Sahel West African greening, low latitude coral reef die-off, and this one doesn't mention ENSO, but some of the tipping points talk about ENSO and the Indian monsoon as well. East Antarctic ice sheet collapse and East Antarctic subglacial basin collapse, and it shows the color schemes of thresholds of less than 2 degrees C. There are other separate warnings that these are teetering over the edge, and some parts of the Greenland ice sheets are also accelerating in their melting, and there are the targets that are reachable with the current policies, which is in the range of 2 to 4 degrees C, and then there are those that are kind of in the business as usual line of emissions into the future. The conclusion of the abstract, the summary, is: our assessment provides strong scientific evidence for urgent action to mitigate climate change. This is urgent anyways in the context of the 1.5 degrees C and 2 degrees C warming targets. The addition of this potential tipping points is supposed to add to the urgency of climate action, I suppose. We show that even the Paris Agreement goal of limiting warming to well below 2 degrees C and preferably 1.5 degrees C is not as safe as 1.5 degrees C, and above risks crossing is not as safe as 1.5 degrees C and above risks crossing multiple tipping points. Crossing these CTPs, climate tipping points, can generate positive feedbacks that increase the likelihood of crossing other CTPs. Currently, the world is heading toward 2 to 3 degrees C global warming. At best, if all net zero pledges and nationally determined contributions are implemented, it could reach just below 2 degrees C. This would lower the tipping tipping point risks somewhat, but would still be dangerous as it could trigger multiple climate tipping points. It could trigger, it would be dangerous, so there are lots of caveats even in the way it's done. Considering these don't come out directly out of the IPCC models, and the IPCC model, IPCC report itself is more cautious about mentioning temperature thresholds for these tipping points. This is kind of a meta-analysis of taking papers that argue for tipping points in different elements and then try to combine them and re-evaluate the thresholds. Okay, so the main paper is titled "Exceeding 1.5 degrees C global warming could trigger multiple climate tipping points." Does this help with climate actions, or does it just create more alarmist messages, more climate anxiety? It's all not clear yet. Climate tipping points occur when change in a part of the climate system becomes self-perpetuating. So there are positive feedbacks beyond a warming threshold, leading to substantial Earth system impacts. Synthesizing paleoclimate observational and model-based studies, we provide a revised shortlist of global core tipping elements and regional impact tipping elements and their temperature thresholds. Current global warming of 1.1 degrees C above pre-industrial temperature already lies within the lower end of some of the tipping point uncertainty ranges. So the uncertainty is critical because it's not easily estimated. There are also papers reporting on the probabilities of these tipping points, again from the same European groups. Several tipping points may be triggered in the Paris Agreement range of 1.5 to less than 2 degrees C global warming, with many more likely at the 2 to 3 degrees C of warming expected on current policy trajectories. This strengthens the evidence base for urgent action to mitigate climate change and to develop improved tipping point risk assessment, early warning capability, and adaptation strategies. All good intentions. So the main thing you have to decide is whether adding tipping points with all their uncertainties in the call to climate action is going to somehow accelerate things, or are we already good enough with the 1.5 to 2 degrees C target and the required actions in terms of all the mitigation and adaptation strategies needed. Of course, if some of the tipping points do happen, then sea levels could abruptly rise, positive feedbacks could happen that could make things much worse at regional or global scales depending on which tipping point is triggered. But this group also had a paper in 2016 after Paris Agreement arguing that the Paris Agreement made good compromises to come up with keeping temperatures below 2 degrees C with this RCP 2.6 representative concentration pathway, bringing us back, drawing down CO2 and reducing emissions and preventing warming and so on, whereas the other scenarios, the middle of the road and higher scenarios, took us into the range where many of these tipping elements would be triggered. So West Antarctic ice sheet, Greenland ice sheet, Arctic summer ice, alpine glaciers, coral reefs. So these are tipping elements possibly switched within the Paris range, and these were considered beyond. But this is now revised in the paper that we are focusing on. There are other studies which pointed out that there are potentially feedbacks between the tipping points which could be positive or negative. So disintegration of Greenland ice sheet is obviously related to the Atlantic meridional overturning. Disintegration of West Antarctic ice sheet is potentially related to disintegration of Greenland ice sheet as well through sea level. Southern Ocean heat accumulation is affected by the AMOC, and these dominoes basically indicate initiator of tipping cascades with number of ensemble members which represent this kind of a scenario or indicate this kind of a scenario, and there are occurrences in tipping cascades. So you can see a Greenland disintegration of Greenland ice sheet would be initiator of tipping cascades to 65%, with occurrence in tipping cascades at 29%, and it's the reverse over here in increased freshwater flux. Without going into details, the idea is that one tipping point being triggered could lead to other tipping points also being affected or brought closer to tipping or tipped based on these kinds of feedbacks. And then there are debates about whether many things like the monsoon and the Arctic sea ice should be considered tipping points at all, and what are the uncertainties. This is a nice paper by Bill Boos. Sorry, this is the wrong reference here. This is the reference. Who looked at simulations with various ranges of radiation forcing, so 16 times the CO2 minus 1 times CO2, albedo being increased to 0.8 from the 0.3 level we have now, sulfate aerosols being increased to 16 times, and black carbon. And the idea of this paper is that the monsoon response seems to be fairly linear to the radiation forcing in very wide ranges. Warming tends to enhance the meridional contrast of ocean land temperatures and increase the monsoon, whereas cooling will tend to damp the monsoon, with some details like the black carbon cooling has a different impact than albedo cooling or the sulfate cooling because of the other details of how global circulation changes based on how the radiation changes created by sulfates, black carbons and albedos, high latitude versus low latitude, ocean versus land, and so on. But the main point was that we cannot simply include everything in the tipping points. So as I said, some of them have been dropped from the list, as we will see in a minute. And the idea was also extended that with these potential feedbacks between different tipping points, there is a potential for a global tipping point that is maybe somehow different than each tipping point. So the idea was to look at this kind of a stability well, where we are going in time from the Holocene into the Anthropocene. So we were at some level during the pre-industrial period since the last glacial melt, and then we have been heading into the Anthropocene since. So this argues that there are pathways where human emissions can take us into the hothouse, so warm well, where you have settled into a very hot Earth, like it happened, let's say, during the Cretaceous, for example. And there are the idea of planetary thresholds for biosphere degradation, and with Earth system stewardship, you could end up with some stabilized Earth, which is warmer than the glacial interglacial limit, but not as dangerous as a hothouse. These are kind of heuristic arguments which continue with the tipping elements and tipping points. So here, the definition in the current science paper we are looking at, given multiple inconsistent definitions of a climate tipping point in the literature, we anchor on technical definition provided by Tim Lenton's paper from 2008, I think. A tipping point is a threshold in a forcing control parameter at which a small additional perturbation within a natural variability of 0.2 degrees C causes a qualitative change significantly larger than standard deviation of natural variability, as shown in reference 1, in the future state of the system. Okay. Here our specific definition is as follows. Tipping points occur when change in part of the climate system becomes self-perpetuating beyond. So after that, even if the forcing is removed, the internal feedbacks will keep it going towards the tipping point. A warming threshold as a result of asymmetry in the relevant feedbacks leading to substantial and widespread Earth system impacts. We now explain key aspects of this definition in more detail. So they go into ideas of irreversible points in the Earth system components, scale, spatial scale, the time scales of these triggers, and the tipping elements, and before going into looking at the results, we should look at the table from IPCC AR6, which is the cross-chapter assessment updating AR5 and SROC. That was a special report that came out in 2018 on the 1.5 degree C, sorry, that's ocean and cryosphere. So SROC of components in the Earth system that have been proposed as susceptible to tipping points and abrupt change, irreversibility, projected 21st century change, and overall change. The main point I want to make out of this detailed table is that the IPCC AR6, which is based on the models, some of which are used in the current paper on advising that tipping points are closer than we think, or will be triggered by reaching 1.5 degrees C global warming, do consider global monsoon, tropical forest, boreal forest, permafrost, carbon, Arctic summer ice, Arctic winter ice, and so on, down to ocean acidification and ocean deoxygenation. And they look at potential abrupt climate change, yes or no, and what is the confidence level they can attribute or assign to this potential abrupt climate change, and look at irreversibility if forcing is reversed, as in mitigation, for example, with the time scales. So, for example, global monsoon is reversible within years to decades, and they can say that with medium confidence, whereas global sea level rise would be irreversible for a century, and we can say this with very high confidence, because if glaciers melt, by mitigating and reducing the warming to, let's say, below 1.5 or below 2 degrees C, you don't build the glaciers back that fast, so the sea level is going to remain. So those kinds of things were considered, and the main thing to notice is that there are no temperature thresholds mentioned here for each of them. So this one, for example, West Antarctic ice sheet and shelves, has a potential for abrupt climate change, and that can be said with high confidence. And this is irreversible for decades to millennia, and we can say that with high confidence because building glaciers takes a long time. And projected 21st century under continued warming, this likely mass loss under all scenarios is expected. Deep uncertainty in projections for above 3 degrees centigrade. So we have to keep these things in mind, and this says added deep uncertainty at global warming levels of greater 3 degrees centigrade as a change in assessment from AR5. These are important because IPCC AR5 is a community that puts together these reports, and then there is this group of authors who do their own analysis and provide heuristic arguments as to why we may be closer to the tipping points. So I'm just saying be cautious about these things because you don't necessarily know the uncertainties. So here, table showing our literature-based threshold, timescales, and impact estimates for the tipping elements we categorize as global core or regional impact, and they do ocean, atmosphere, biosphere, cryosphere with these different colors. And proposed climate tipping elements and tipping points include Greenland ice sheet, West Antarctic ice sheet, Labrador Erminger Sea, and South Pacific, subpolar gyre convection, which relates to Atlantic meridional overturning circulation, AMOC, which is down here, East Antarctic subglacial basins, and so on. And thresholds are provided with estimated minimum and maximum, and timescales are provided again with estimated minimum and maximum, and maximum impacts are provided at global and regional levels. So lots of details, but also lots of uncertainties that go with them. And personally, for me, it's unclear how this is going to alter the action plans for climate change. Just adding another uncertain element to the already uncertain projections may or may not add, especially if we hit 1.5 degrees C and none of the tipping points have been triggered, then credibility can be an issue as well. Okay, it can become a political football to say this these projections are completely wrong. Okay, so we have to keep those things in mind. Nonetheless, here is a map showing global core and regional impact climate tipping elements identified in this science paper. And again, they include pole to pole for global and regional impacts. So Arctic winter ice, as we said, not everybody thinks this would be considered a tipping point. Boreal permafrost, Greenland ice sheet, Labrador Sea subpolar gyre convection, AMOC, Amazon rainforest, boreal permafrost, and so on. And also West Antarctic ice sheet, East Antarctic ice sheet, and East Antarctic subglacial basins. In the regional section, we have again boreal permafrost, Barents Sea, boreal permafrost here, boreal forest. These are the mountain glaciers, loss, coral reefs, Sahel, West African monsoon, extrapolar mountain glaciers, and low latitude coral reefs, and so on. This is their kind of summary figure showing warming thresholds in a graphical format. Since I'm asking you to be skeptical due to the uncertainties about adding these to the projections and global warming targets, I will not go into great detail, but you can see the global warming relative to pre-industrial is shown here with 1 degree, 2 degree warming and 3 degree warming with various levels of risks of tipping triggers estimated. So minimum estimate, maximum, and central. So possible at this bottom range, likely in this range, and above that tipping very likely. So obviously when you hit this kind of warming, you can expect many will be very likely. But the question is, in the range that we are aiming for under Paris Agreement with revised nationally determined contributions of 2 degrees C and 1.5 degrees C, how should we take these revised estimates of when the risk of tipping actually occurs? So this is the range of warming expected with current policies, with net zero policies, and the Paris range if we go with the shared socioeconomic pathways, which promise to get us into negative carbon emission scenarios. Then we would maybe even come down to 1.5 with the range expected here, as we have seen in other podcasts. So I won't go into these cumulative and per decade potential threshold crossed, because I'm not sure how I would explain the uncertainties in these things. So climate tipping points are there in the system, but so are the asteroids and volcanoes and earthquakes. So you have to place in context the probabilities. The difference between earthquakes, volcanoes, and asteroids is that with greenhouse gas emissions, we are constantly pushing the system towards warming and the triggering of tipping points. So we have to be careful, but the uncertainties are still something I worry about. The main conclusion from the paper is the UNFCCC, United Nations Framework Convention on Climate Change, stipulates that all countries commit to avoid dangerous climate change, translated through the Paris Climate Agreement into keeping global mean surface temperature well below 2 degrees C and aiming for 1.5 degrees C. Our assessment of climate tipping elements and their tipping points suggests that danger may be approached even earlier. So these statements are, people who actually do the IPCC assessment are obviously much more cautious about this. The Earth may have left a safe climate state beyond 1 degree C global warming. Again, another statement that is kind of empirical. A significant likelihood of passing multiple climate tipping points exists above 1.5 degrees C, particularly in major ice sheets. Tipping point likelihood increases further in the Paris Agreement range of 1.5 to less than 2 degrees C warming. Current policies leading to 2 to 3 degrees C warming rate are unsafe because they would likely trigger multiple climate tipping points. Our updated assessment of climate tipping points provides strong scientific support for the Paris Agreement and associated efforts to limit global warming to 1.5 degrees C. So, in short, the global warming target is good and it's agreed upon, and it should be the focus. Adding more uncertain statements about tipping points, in my view, may not necessarily help accelerate the action. So we should stick to mitigation and adaptation as we want to do under the global warming targets agreed upon in the Paris Agreement. Okay?